Okay guys, today's lesson on section 6.7 is going to involve the product to sum and the sum to product formulas that you see on the first page of your notes. And we're going to go ahead and jump straight into example 1 here. So on example 1, I see that this is a product of a sine and a cosine, and so I'm going to use the third formula in the first box on the front page of your notes. Okay, and so this expression is going to become 1/2 sine of the sum of the angles, so this is going to be 225 plus 75, and then plus sine of the difference of the angles, so that will be 225 minus 75. Okay, if I continue going here, just simplifying, so this is going to end up being sine of 225 plus 75 will be 300, plus the sine of 225 minus 75 is going to be 150. Okay, and now I just need to find those exact values off of the unit circle. So for sine of 300, I know that 300 is in quadrant 4, and so that's going to make the answer negative since sine is negative in quadrant 4. And then the reference angle is 60 degrees, and sine of 60 is the square root of 3 over 2. And then for sine of 150, I know that that's in quadrant 2, so that's going to be positive since it's sine in quadrant 2. And then the reference angle is 30, and sine of 30 is 1/2. And you are more than welcome to leave that as your final answer. All right, on example 2, I noticed that I have the product of two sine functions. And so I'm going to use the first formula from the list for the product to sum formulas, which says that this is going to equal to 1/2 cosine of the first minus the second, so 7 theta minus 4 theta, and then minus cosine of 7 theta plus 4 theta. And then I'm just going to simplify that by actually collecting the like terms, and so this will be cosine of 3 theta minus cosine of 11 theta. And that's all I need to do in order to write that as a sum that contains only sine and cosine. On example 3, I notice that I have the product of a sine and a cosine, so I'm going to be using the third formula from your list for the product to sum, and so that's going to say that this is the same thing as 1/2 sine of alpha plus beta, so that'll be 7 theta plus 4 theta, and then plus sine of alpha minus beta, so that'll be 7 theta minus 4 theta. And then again, I'm just going to simplify those, so it'll be 1/2 sine of 11 theta plus sine of 3 theta, and I'm done. Okay, so it's very basic application of those formulas that you have on page 1 of your notes. All right, in example 4, I have the product of two cosines. Now, 6 theta is before 8 theta. That doesn't really matter. I'm always going to, whenever I do the subtraction, I'm always going to do the bigger one minus the smaller one, and it's not going to really make that much of a difference. So using the second formula from your first list of formulas on page 1 of the notes, this is going to be 1/2 cosine of 8 theta minus 6 theta, and then plus cosine of 8 theta plus 6 theta. And so that ends up becoming 1/2 of cosine 2 theta plus cosine of 8 theta plus 6 theta, which is 14 theta. Okay, starting with example 5, now we're going to use our sum to product formulas to express the given sum or difference as a product of sines and cosines. So in example 5, I have a sine minus a sine, so that means I'm going to be using formula 2 to say that this is equal to 2 sine of alpha minus beta over 2, so that'll be 7 theta minus theta over 2, multiplied by cosine of alpha plus beta divided by 2, so that's 7 theta plus theta divided by 2. So, doing some simplifying here, this becomes 2 sine of 6 theta divided by 2 times cosine of 8 theta divided by 2. And so that will become 2 sine of 3 theta multiplied by cosine of 4 theta. Okay, so just doing some simplification after using the initial identity. Okay, this is also the sum of 2 cosines, and so I'm going to use the third formula that you see on the sum to product list. Okay, and so that formula says 2 cosine of alpha plus beta over 2. So in this case, that'll be theta plus 5 theta over 2. And then multiplied by cosine of alpha minus beta divided by 2. And again, I'm just going to do the bigger one minus the smaller one. Okay, divided by 2. And so this is going to be 2 cosine of 6 theta divided by 2. Multiplied by cosine of 4 theta divided by 2. And then just go ahead and simplify. So 2 cosine of 3 theta times the cosine of 2 theta. Okay, this is the sum of 2 sines, and so that means I'm going to use formula 1, which says 2 sine of alpha plus beta, so that would be theta plus 7 theta over 2, multiplied by cosine, and then subtract 7 theta minus theta over 2. And so doing some simplification, just like before, this is going to be 8 theta divided by 2, cosine of 6 theta divided by 2, and then go ahead and simplify those by reducing the fractions. So sine of 4 theta, cosine of 3 theta. Okay, we're going to move into a couple of problems where we're going to establish some trig identities. So in this first one, what I notice is that in the numerator, I have the difference of 2 sine functions. So I'm going to use my sum to product formula, the one that involves the sine minus the sine, okay, which is the second formula in your list on sum to product. And so what that formula says is that this is 2 times the sine of alpha minus beta. So in that case, this is going to be theta minus 3 theta over 2. And that means that the next part is going to be cosine of them added, so theta plus 3 theta divided by 2. And that is going to all be over 2 cosine of 2 theta. Now, this is going to become, on the next line, 2 sine of negative 2 theta divided by 2, cosine of 4 theta divided by 2, divided by 2 cosine of 2 theta. Okay, which is going to become 2 sine of negative theta multiplied by cosine of 2 theta divided by 2 cosine 2 theta. And what you should notice now is that the 2's are going to cancel, and the cosine 2 thetas are also going to cancel, and that's going to leave me with sine of negative theta. Wow, I do not know why I put an infinity sign. Sorry about that. I'm going to try that again. Sine of negative theta. And if you look at our target back up here, we're trying to make it say negative sine of theta. Well, using an even-odd identity, I know that I can write this as negative sine of positive theta. That's using an even-odd identity. In fact, in this case, it's really using the odd identity for sine, and so that's how I get to the final answer. Okay, and in example 9, we have sine of 6 theta plus sine of 4 theta in the top, and so I'm going to use a sum to product formula on that, which will be the first one since it's a sine plus sine. So that will be 2 sine of alpha plus beta over 2, so 6 theta plus 4 theta divided by 2, multiplied by cosine of 6 theta minus 4 theta over 2. Okay, and then in the bottom, I see that I have a cosine plus a cosine, so that means I'm going to use the third formula to help simplify that. So that's going to be 2 cosine of alpha plus beta over 2, so that means I'm going to add them, 6 theta plus 4 theta divided by 2. And then I'm going to have cosine of them subtracted and divided by 2. Okay, so going ahead and simplifying this, I'm going to have 2 sine. Do a little bit of mental math here, so I'll point out what I'm doing here. In this fraction right here, 6 theta plus 4 theta is 10 theta. Divided by 2 is going to be 5 theta. So I'm just going to skip a couple of steps there. And then cosine 6 theta minus 4 theta is 2 theta. Divided by 2 is just going to be regular 1 theta. And in the bottom, I'm going to have something similar. I'm going to have 2, and then I'm going to have cosine of 5 theta multiplied by cosine of theta. Okay, and then some nice things start to happen. The 2's are going to cancel here. The cosine thetas are going to cancel, and so that's going to leave me with sine of 5 theta over cosine of 5 theta. And using a quotient identity, I know that that's the same thing as tangent of 5 theta, which is what my answer needed to be. Okay, in the last example, example 10, we want to solve this equation on the interval from 0 to 2 pi. And so what I notice is that it's the sum of 2 different types of sine functions. And so I'm going to, once again, use a sum to product formula. In this case, I'm going to need to use the first one, since it's a sine plus a sine. So this is going to say 2 sine of them added together and divided by 2. So that's going to be 6 theta divided by 2, which is going to end up being 3 theta. And then multiplied by cosine of them subtracted and divided by 2. And so that's going to be 2 theta divided by 2, which will be theta. And then this is equal to 0. So I'm ready to set all 3 of these things equal to 0. So the sine of 3 theta is equal to 0. And then the cosine of theta is equal to 0. Now I'm going to start with the one on the right because it's a little bit easier. So for cosine theta equals to 0, remember that cosine is the x-coordinate. And so the x-coordinate is going to be 0 at the top and the bottom of the unit circle, which is going to be pi over 2 and 3 pi over 2. Now for this other one, we need 3 theta to equal all of the places where sine is equal to 0, or the y-coordinate. And so that's going to be whenever we're at the right or left hand part of the circle. And so that's going to be 0 and pi. But because this says 3 theta, I'm going to need to keep going until I get all the way to a certain number. And so I'll kind of talk through that as I'm going. So the next number would be 2 pi. Okay, the next number after that would be 3 pi. If I divide 3 pi by 3, which I'm eventually going to do because of the 3 right here, that's still going to be less than 2 pi. So that means I need to keep going, which would be 4 pi. That answer would be 4 pi over 3, so that's too big. I need to keep going. I need to go to 5 pi. 6 pi is actually going to be the one that I'm not going to write down, because if I were to write down 6 pi and then divide that by 3, that would give me 2 pi, and that is not on that interval. So 5 pi is going to be the last number that I write down there, and then I'm going to divide all of the answers by 3 so that I get theta is equal to 0, pi over 3, 2 pi over 3, 3 pi over 3, which of course reduces to pi, 4 pi over 3, and 5 pi over 3. And notice that all of those answers are between 0 and 2 pi. So I have this set of answers right here to go along with this set of answers right here for a total of 7 answers to this equation on the interval from 0 to 2 pi. Okay, hope you guys understood that okay. If you have any questions, then please feel free to let me know.